We're going to fill out a complete unit circle. We've already done pieces of this, but we want the entire thing in one place. So we're going to start out with the degree measures. Okay. As always, we start at the positive x-axis and then count in 90-degree intervals. So 0, 90, 180, 270, and back to 360. This line always gets 2 angle measures. Now halfway in between those, we get the 45-degree angle marks. So halfway between 0 and 90 is 45. Halfway between 90 and 180 is 135. Halfway between 180 and 270 is 225. And halfway between 270 and 360 is 315 degrees. Now for the rest of them, I'm going to start counting by 30s. 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. These are all my degree measures. Now I'm going to do radians. I'm going to do it in the same manner. So I'm going to start at 0 and then pi over 2, pi, 3 pi over 2, 2 pi. So I'm counting by pi over 2 intervals. Halfway in between those, I have the pi over 4s. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And now I'm going to start counting by pi over 6s. Pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. Of course, I was reducing the fractions as I went. Now, I'm going to fill in the coordinate points, which are always as, of course, cosine, comma, sine. This is the point 1, comma 0, 0, comma 1, negative 1, comma 0, and 0, comma negative 1. Now here, I'm going to fill in the first quadrant based on what we've already learned about the special triangles, and from there I'm going to copy it into all the other ones. 30 degrees has a cosine of square root 3 over 2 and a sine of a half. 45 degrees, they're both root 2 over 2. And 60 degrees is 1/2, comma root 3 over 2. Now there's patterns for everything else. First of all, they're always going to mirror each other. So everything that was here will be copied in a mirror image over here, only adding negative signs on the x-coordinates since we are now in quadrant 2. So minus the half, square root 3 over 2. Minus root 2 over 2, positive root 2 over 2. Minus root 3 over 2, 1/2. I'm going to again take this quadrant and mirror it down here, only in quadrant 3 both the x and the y coordinates are negative. And for quadrant 4, I can either mirror it from quadrant 3 or from quadrant 1. In quadrant 4, y coordinates are negative. So in addition to these patterns that appeared when I mirrored the quadrants, they also show up in the degree and the radian measures. If you notice the radian measures, the pi over 6 is always mirrored into a pi over 6. The pi over 3 always mirrored into a pi over 3. Furthermore, there's other patterns. The numerators in quadrant 1 are always 1 pi. The numerators in quadrant 2 are always 1 less than the denominator, and of course a pi. The numerators in quadrant 3 are always 1 more than a denominator. And the numerators in quadrant 4 are always 1 more than twice the denominator. So for instance, 7 is 1 more than 8. Okay. There are so many patterns in here, but the largest one is that if you can fill out quadrant 1, you can actually mirror it into all the other quadrants by simply adding the appropriate negative signs.